Welcome to Dynamic Educational Hub channel, your answer to the very question. This is the first video in this playlist, Coordinate Geometry. As usual, we are going to start learning the basics. So if you are struggling with mathematics or you find it difficult to understand mathematics, believe me, choosing this playlist, we are going to understand one aspect of mathematics, which is coordinate geometry. So if you are struggling with how to plot graph in physics, how to plot your graph in mathematics, this playlist is actually useful for you. So I'm not going to bore you with the origin, but we are going to learn the basics. Previous knowledge that are bedrock in learning coordinate geometry are topics like trigonometry and Euclidean geometry, and I have a playlist that treats the two topics very well, so you can check it out as well. All right, without further delay, let's start the class.
The first thing we are going to learn is coordinate system, the meaning of coordinate system. And to start with, now let's say we have a free space as shown, an empty space, and you want to describe the position of an object in an empty space. It will be very difficult for you to give the location of that point because it is an empty space.
So to describe the position of any object in space or any point in space, you will be needing a reference position, a reference object. Since empty space, you have nothing in empty space, so you can describe the position of new object in that space.
Now we have a room. Now in this room, we have the wall, we have the floor, and we have flower vase. We have flower here, we have flower and flower vase. Now this is not an empty space. We already have wall, floor, and flower vase. Now let's have a ball in this room. This ball, you want to give the position of this ball. You want to tell it to someone, or you want to tell someone to bring you this ball. Now, when you want to describe the position of this ball, you can use the wall. Using the wall, you tell that person that the ball at the front of the wall. So this ball, you can also say that the ball that is beside the flower vase, or the ball that is beside the flower, what we have here. You can also say that the ball that is on the floor, this ball here. So that is the position, the preposition of this ball. Now, what will happen when you have multiple balls in this room? Let's say you have two different balls in this room and you are not differentiating this ball. You just ask someone to get you a ball inside this room and you want to give the position of that ball. Mind you, these two balls, we are not differentiating between them, but their position is different. Now, it will be very difficult for you to give the exact location of this ball. What do I mean? Now, let's go. This ball is also at the front of the wall. This ball is shown at the front of the wall. This ball is at the front of this ball, as shown. It's also at the front of this flower vase, and this ball is also on the floor. And now, any observer that is here that wants to pick this ball using a description. We have two balls that is at the front of the wall. We have two balls that is at the front of the flower vase or flower. And we also have two balls that is on the floor. So choosing that preposition or any preposition you want to use will not give the exact location of this ball since we have multiple balls. Now, coordinate system is going to take care of that. Coordinate system will give the precise and exact location of points in space. So coordinate system is a way of representing the location of points in space. To give the location of points objects, buildings, anything in space, we use coordinate system. So we have types of coordinate system. Now we have geographical coordinate system. So we are going to limit ourselves to just 3 types of coordinate system. First one is rectangular or Cartesian coordinate system. We are very familiar with this one. This is the basics of plotting a graph. Rectangular coordinate system is what we have here, the 3D form of rectangular coordinate system. We also have polar coordinate system here, which is also the 3D form of polar coordinate system, which is called cylindrical coordinate system we have here. And we also have spherical coordinate system, what we have here. Now the question is, why do we have multiple types of coordinate system? Why not just a single coordinate system? Now the reason why we have different types of coordinate system is because of the suitability of a coordinate system to describing a particular point in space. What did I mean? Now, if you have a flat surface and you want to give the location of points on flat surface, the best coordinate system that you can use is Cartesian or rectangular coordinate system. Now, if you have a circular flat surface, now the best coordinate system that you can use is polar coordinate system, the 2D form. Now, if you have a spherical object, for instance, Earth, and you want to give the coordinate, the location of a particular spot on Earth, the best coordinate system that you can choose is spherical coordinate system. And that is somehow similar to longitude and latitude. That is why we have different type of coordinate system. Anyone you are choosing or you are adopting it in such a way that it will easily describe that point in space. And don't forget, every coordinate system will always have a reference point, as this. Cartesian or rectangular coordinate system. Now this is the basics of plotting graph. Now Cartesian system represents points in plane by using 2 or 3 unique numbers, either positive, negative, called coordinates. Now these numbers are assigned from 2 fixed perpendicular to the plane, which means x and y, or 3 fixed perpendicular lines known as 3D plane, x, y, and z. What it means that Cartesian or rectangular coordinate system is in 2 forms. We can have the 2D form, which means flat surface. When you are describing a point along a flat surface, you are plotting your graph, 2D graph. Then you have your x and y, that is 2D Cartesian coordinate system. And we also have 3D Cartesian coordinate system. This is when you have your x, y, and z. For instance, in your room, let's say we have a room, then you want to describe a particular spot of an object in your room. Your room is a space, 3D space. Now you can adopt 3D Cartesian coordinate system. Now for 2D Cartesian coordinate system, we are going to have 2 references, which is we have y axis, y coordinates as shown. We have x axis as shown, which is known as x coordinate. For y axis, y coordinate, it is usually vertical line. So we have it here, vertical, and we have horizontal, which is usually x coordinate, x axis. What we have here, the angle between them is 90 degrees, so which means the 2 axes are perpendicular to each other. Now let's say, for instance, you want to give the coordinate of this point as shown. What do you need to do? You need to trace this point, you trace it, you draw an horizontal line along until you reach your y-axis. Now that y-axis, whatever value you get here is the y-coordinate, and you also trace it down or upward depending on the orientation of that point until you get to your x-axis, the reference, the x-coordinate, and whatever coordinate you have here, that's represent the x coordinates. So you have your X and Y coordinates. Now for 3D Cartesian coordinate system, we are going to have 3 references. So we are using 3 references, 3 reference axes, which is you have your X, Y, and Z. Mind you, the axes are perpendicular to each other, so which means we are going to have 3 different planes. Like this one that we have just a single plane, we have X and Y plane. For 3D, we are going to have 3 different planes. Let's quickly differentiate between the 2D and 3D. Now for your 3D, we can see here that the vertical axis, here we are using Z. We call it Z axis. Z axis. The vertical part, we call it Z axis here for 3D form. Now let's say you want to describe this point along YZ plane. Now you just trace it. Now you have your what? Your Y and Z. Now let's say here, this point which is along the flat surface which is on X and Z plane. So we are going to have your X and Z coordinates. Now on the floor here, you are going to have your X and Y coordinates. Now let's say you now have this one that is not on any plane. This point, you want to describe the position. It's quite simple. What you need to do is you start drawing parallel lines along each axis. So when you draw it, you get this. Starting from each plane, now you draw a parallel line to y-axis. Starting from here, you measure it along this. You draw a parallel line to x-axis. Starting from here, you measure it. You draw a parallel line to z-axis from the floor, from the origin, from the floor, and you draw it upward, and then you can read your x, y, and z. For polar coordinate system, instead of having numbers to describe the position of points in space, just like a Cartesian coordinate system. Now for polar coordinate system, we are going to measure distance from a reference point, and we measure angle from a reference coordinate. This is polar coordinate. So this uses distance and an angle to define the position of points in plane. The distance is usually from a reference point called pole, and the angle is measured from a reference ray which is known as polar axis. Now the angle can be given in degree or radian. Now polar coordinate is denoted by r theta. The theta can be degree or in radian. When you have polar coordinates in which you only measure distance and angle, we call it 2D polar coordinate. And we can also have 3D polar coordinate, just like Cartesian coordinate that we have 2D and 3D. The same thing is applicable to polar coordinate system. Now for 3D polar coordinate system, we are going to measure 2 things. The first one is we are going to measure distance from a reference point, which is known as r. We measure our angle theta from a reference polar axis. Then we measure the z coordinates, the coordinates that correspond to z in Cartesian coordinate system, so which is the height of that point in 3D space. So which means we have linear measurement, we have angle, and we have a coordinate that corresponds to Cartesian coordinates here, which is the height. Now you can also have it as r theta, and pp also means z here, and that is 3D polar coordinates. Now for 3D polar coordinates, it also has another name, which is cylindrical coordinate. So it's either you call it 3D polar coordinates or cylindrical coordinate, but most time it is called cylindrical coordinate. Now let's learn it properly. Now let's have the 2D form. Now let's say you want to describe this point. The first thing is you have a reference point as shown, and you can draw the distance from that reference point to the point you want to give the coordinates. and that distance you call it your r, which is the radius. The next thing is, from this reference point you are going to have polar axis, which is called reference ray, and the polar axis also corresponds to the x coordinates in Cartesian 2D Cartesian coordinate system. So just like your x axis, now you have it here. So this is polar axis, which corresponds to the x axis. Then you can take your measurement going anti-clockwise, the measurement of angle going anti-clockwise, and that is theta. You can have it in radian or degree. Now you can be given the other angle here, and you should know that this other angle will be 180 degree minus theta. Yeah. So we have the measurement of the distance, which is r, the measurement of the angle starting from your polar ray, which is polar axis, going anti-clockwise until you get to the line. Then you have r theta. Now you can easily convert this using trigonometry to Cartesian coordinate system, to the Cartesian coordinate. Using your trigonometry, you get this one is r cos theta and this one is r sin theta. We are still going to learn that. Then for cylindrical coordinate system, the first thing is we have the axis in 3D form, which is we have our x and y and z axis. You have it here. Now we are talking about 3D form now. So you have your x, y, and z. Now, looking at this floor here we have what we call xy plane. We have xy plane. Now, describing any point here, you are going to have x, y, just like when I explained 3D Cartesian coordinate. Now we also have another plane here, which is xz plane. Describing any point here, you are going to get x, z. Now finally we have another plane here, which is we have yz plane. Describing any point here, we are going to have y and z. Now because I want to avoid optical illusion, so I'm cleaning one plane to describing the cylindrical coordinates. Now we want to give the coordinates of this point, the polar coordinate of this point in 3D space. The first thing is we are going to take the z coordinate measurement. What do I mean by z coordinate measurement? So we draw a vertical line downward. So this is the z coordinate, so which is a line that is parallel to z axis. We draw it downward. Now the next thing is to find our r. So r is a line from the origin, which is the reference point, up to the floor here. So let's go ahead and draw it. So we have it as shown. We can also draw a parallel line to that r, starting from this point until you reach your z axis, and that is our r. That is the radius we are measuring here. Now the next thing is we need to measure our theta, which is the angle. Now measuring the angle, remember your angle is measured starting from the x-axis going anti-clockwise. Now starting from your x-axis, you measure the angle, and the angle is called the theta. So the last measurement is the z coordinate here, the first thing that we've done. So this is our r here, this is our theta here, and this is our z coordinate here. That is cylindrical coordinate system. Now why are we calling it cylindrical coordinate system? Let me show you that. Let's have another point. Let's say this point. So we want to get the coordinates, the polar coordinates, the cylindrical coordinates. The first thing is we draw it downward. We have our r as shown.
You can see that when we revolve the radius along the z-axis, just like rotating it along the z-axis,
and you consider the height. You are revolving this, considering the height, you are going to get the shape that is shown, which is cylinder. And that is why it is called cylindrical coordinate. Revolving it around the z-axis, considering the height, just like you are extruding it, you are going to get cylinder as shown. That is why it's called cylindrical
A
coordinate.
coordinate system that is similar to cylindrical coordinate system is spherical coordinate system. Spherical coordinate system, it uses a distance and two angles to describe the position of points in 3D space. Now it is a slight variation of cylindrical coordinate. Recall that cylindrical coordinate, we have a linear measurement, which is the radius, and the radius is from the origin down to the point when you reflect the point from the height to the base. So I'm still going to explain that. Unlike cylindrical coordinate, now cylindrical coordinate uses r, small letter r, theta, and this phi. Now this small letter r is the radius, the distance between the origin and the point. You see, that's the difference between the capital letter R for cylindrical and this. Now this theta is still the same from cylindrical coordinate system, while this phi is an angle that is measured from the z coordinate, moving clockwise until you get to the r. So where r is the distance of the point from the origin, theta is the angle measured from x-axis, and phi is the angle measured from z-axis. Now to get a better understanding of that, now we have our y, x, y, z axis as shown. Now this is a sphere. Now we want to describe the position of this point as shown. Recall that this point here, we can just have something that looks like this. From longitude and latitude, we have this diagram as shown. Now the first thing is, let's give the radius. The radius is this from the origin down to that point. So this is a sphere. Now you have the radius from here to here. This is the radius, which is the small letter r that we are measuring the distance. The second thing is to measure the angle. How do we measure this theta? Now we are going to adopt cylindrical coordinate system. Now you have to trace down this until you get to the floor, then you connect it to the origin as shown. Now this is the capital letter R from cylindrical coordinates. You know we are not using it, but let me show you what we are using. Now you measure an angle from x-axis, moving anti-clockwise until you get here. So this is theta, the second measurement. Now the last measurement is the angle between the z-axis and your radius, which is the phi. Now this is the phi. This is spherical coordinate. You have your radius, small letter r. We are using this, not this. This one is for cylindrical. Then we have our theta. Don't forget that this theta is still the same thing with the angle that we measure in cylindrical coordinate system. Finally, an extra angle, which is phi, this angle. This is why it is called spherical coordinate system.
Now that we have learned the major coordinate system here, now we are still going to learn the relationship between the coordinate system that we have learned so far, rectangular coordinate system, polar coordinate system, and spherical coordinate system. So we are still going to learn the relationship between them, the difference relationship, and how we can convert one coordinate system to the other coordinate system. Now before I go, let me quickly do a recap of what we have learned so far. The first thing that we learned here is we learned coordinate system. That coordinate system is a method of representing the position of points. It can be object, it can be anything or point in space. And here I talked about 2D space and 3D space. Now we have different types of coordinate system that we can use. We have Cartesian coordinate system. Cartesian coordinate system can be 2D or 3D as shown. We have polar coordinate system. Polar coordinate system can be 2D, 3D, and we also have spherical coordinate system, which is just 3D. For Cartesian coordinate system, that is 2D, we have X and Y. So we are going to have two axes, X axis and Y axis. We use it to represent points in flat surface. Now we have 3D coordinate system. We have X, Y, and Z, and all these coordinates are perpendicular to each other. Then we have polar coordinates. Polar coordinates is using distance and angle. Now the angle is taken from the X axis or the polar axis, and you have your radius, the distance between the point, reference point, and the object that you are representing the position, or the point you are representing the position. We also have polar coordinates in 2D and 3D. The 3D form is also known as cylindrical coordinates, where we have our radius, you also have your angle, then you have the height which corresponds to the Z axis in 3D Cartesian coordinate system. Finally, we talked about the spherical coordinate system, which is a little bit different from cylindrical coordinate system. It's just a slight variation of cylindrical coordinate system. Here we are having 3 measurements. We have 2 angles and a linear measurement. Linear measurement is small letter r, which is the radius. Now the radius for spherical is different from the radius of cylindrical. Now the angle, one angle out of spherical coordinate system corresponds to the angle in cylindrical coordinate system, and the other angle, which is phi is a Greek symbol, and that phi is the angle that is taken from Z axis. And before I end this video, here is an interesting question that you can see here. Now this will test our knowledge about the coordinate system that we have learned so far. Now the question is, which coordinate system is suitable for describing the following? The first one, for tracking the movement of aeroplane. The second one, tracking the movement of football on the pitch. The third one, for finding the position of fish in a pond. The fourth one, which is the last one, for finding the position of a text that is written on a paper. So if you are the one that wants to adopt a coordinate system for all these cases, which one are you going to adopt out of Cartesian, polar, or spherical coordinate system? They are 2D or 3D form. Which one are you going to adopt? So you can comment your answer in the comment section. Let's see the reason why you are picking one of these coordinate system as a coordinate system you will use to describe the following case. All right, thank you for watching this video. Thanks for watching my videos. Thank you for watching this video. And if you haven't subscribed to this channel, kindly subscribe to this channel. I have many videos that I'm here to release. I'm cooking many videos, so I also have different playlists here in this channel. So I have playlists for learning mechanics, playlists for learning matrix, playlists for learning trigonometry, Euclidean geometry as well, and even heat energy videos that you're going to love. All right, stay blessed. See you in the next video. In the next video, we talked about Cartesian coordinate system, how we can use it. All right, see you in the next video. Bye for now.